Assalamualaikum warahmatullahi wabarakatuh and a very good morning I bid to all my fellow friends. Okay, today we from group 6 would like to present to you about ammonia production. Before we go further, I will introduce you my group member. Okay, firstly, my name is Muhammad Syarul Azim bin Azmin, and my next member is Muhammad Naufal bin Salim. Thirdly is Muhammad Fauzan Syafi bin Muhammad Faudi, and lastly is Muhammad Denish bin Cik Abdul Aziz. All of the number metric are on your screen. Okay, today I will introduce you about ammonia. Okay, ammonia is the covalent compound, and it is compound of nitrogen and hydrogen. Next, ammonia is the colorless gas with a distinct pungent smell. Thirdly, in its contract form, it is caustic and dangerous. Next, the major of use of ammonia is the first fertilizer. And lastly, ammonia is also used to manufacture commercial explosive like TNT. Okay, we go to the next slide. Two resources to make hydrogen. First is hydrogen. Hydrogen conventionally obtained from the fossil fuel such as natural gas or coal. Next method to get hydrogen is use electricity generated by renewable energy sources like wind, air, solar, biomass, or anything to obtain hydrogen from electrolysis. Okay, the second thing that you must get to make ammonia is nitrogen. Nitrogen we get from air by using method electrolysis. Okay, the method that they use to make ammonia is Haber-Bosch process. This method that be applied in this era. Okay, this method is using hydrogen and nitrogen gas as reactant of this process to make ammonia. Okay, that's all from me. Thank you. I proceed to my next member, Fauzan.
Hello, my name is Mohammad Afal bin Salim, and today I want to show you the process diagram and calculation of ammonia processing. First of all, in this diagram, we have the feed compressor, which is used to maintain the pressure of gas. On the second hand, we also have the heat exchanger. It is used to transfer heat from one medium to another. Then we have the ion catalyst. This reactor has ion catalyst and the temperature around 400 degrees to 500. And then we have the cooler, which is used to cool down the, the substance after being heated in the with around 400 to 500 degrees. Next one is the calculation. For this process, we use the equilibrium constant formula to determine the mole, which is product per reactant equals to 1, which is the equilibrium constant. Next one, to determine the mole of the input, we assume that 100 kg of each ammon of each nitrogen and hydrogen. Then we use the stoichiometric ratio to determine the mole. With that, we can find the excess and limiting reactant by dividing the smallest number. After that, we can calculate the mole and mass of ammonia, which is by using stoichiometric ratio. Next one, by using the previous formula, we can use it to determine the output of each product, which is the output of hydrogen, nitrogen, and ammonia. And finally, we will have the mole of the output species, which is for hydrogen 46.43 mole per hour and for nitrogen 2.38 mole per hour. And that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fauzan Shafi bin Muhammad Fodi, and I will continue this presentation with a project description. Okay, now we will look at this flow diagram of the absorbent intense ammonia synthesis process. Although the absorption is inherently transit, the use of the two absorber vessels allow for a cycle steady state operation. Naturally, the process can be divided into two parts, which is the reaction absorption and the desorption. The reaction absorption loop is feed 100 kg of stoichiometric mixture of nitrogen and hydrogen each. These gases are compressed to the process operation pressure, which is between 14.8038 and 29.6077 atm. Before being sent to the heat exchanger, which heat the feed of gas to reaction temperature, which is around 400 degrees Celsius, using the reactor influent. Next, the nitrogen and the hydrogen then react to form an ammonia in fixed vessel containing a Wusteel-based ion catalyst, which is the industry standard. The reactor influent is partially cooled with the heat exchanger mentioned above and then cooled further with the cooling water to the absorption temperature, which is around 100 till 200 degrees Celsius. The absorber is a fixed vessel of a magnesium chloride support on silica that serve to selectively remove the ammonia through a solid absorption. The absorber influent, which consists primarily nitrogen and hydrogen with some unabsorbed ammonia, is then cooled to be ensure the recycle compressor is safe operation as it discharge a temperature that cannot be exceed than 150 degrees Celsius. The fresh feed is mixed with these gases. At the end of the absorption cycle, once the absorber is deemed to be saturated, it is regenerated through a combination of heating to between 400 till 500 degrees Celsius. And it will decreasing the pressure by opening one of the end of the vessel. This causes a reduction in the ammonia storage capacity of the absorbent, and subsequently, ammonia is released to the gas phases. This gas leaves the bed through the open end due to the input of the pressure gradient. The absorber influent is cooled, compressed, and condensed so that it can be stored in as a liquid. The release of the ammonia occurs until the absorbent has been empty, and the bed pressure is equal to the pressure outside of the vessel. Once this occurs, one bed volume of stoichiometric nitrogen and hydrogen is fed to the bed to displace the gases of ammonia. The emptied bed is repressurized to the reaction absorption pressure, which is stoichiometric mixture of a nitrogen and a hydrogen, and then we connect to the reaction absorption loop. That's all from me. Thank you.
Advantages of a production of ammonia in industrial application: use as a refrigerant gas and in air conditioning equipment. Ammonia can absorb substantial amount of heat from its surrounding. Next, ammonia is safe for the environment with an ozone depletion potential ODP rating of 0 and a global warming potential GWP rating of 0. This is because ammonia is substantially less expensive than CFC and HCP. In addition, ammonia can be used to purify water supplies and as a building block in the manufacture of the many products, including plastic, explosive, fabric, and dyes. Ammonia is also used in a waste and wastewater treatment, cold storage, rubber and food beverage industry as a stabilizer, neutralizer and a source of the nitrogen. One of the ammonia disadvantages is that it causes copper alloy corrosion, especially in a moist environment. So you need partliness heat exchange and fitting are made of steel. Other than that, ammonia is a substance with a strong odor and is harmful to human organism. Assalamualaikum warahmatullahi wabarakatuh. Next, I will present the conclusion of production of ammonia. As we know, ammonia is a colorless alkaline gas that is lighter than air. It is used as a fertilizer, refrigerant in medicine, and in making dyes, textile, plastic, and explosives. Ammonia is a 3 to 10% more efficient refrigerant than CFC. So, an ammonia-based system requires less electricity, resulting in a lower operating cost. Ammonia is a building block for ammonium nitrate fertilizer, which releases nitrogen and essential nutrient for growing plants. Fertilizer can also help increase the level of essential nutrients like zinc, selenium, and boron in a food group. Lastly, ammonia has a good features as a working medium in a variable power refrigeration. That's all for my group. Thank you.